Welcome back to the next video. Please subscribe my channel and press the bell icon. Initially, only decomposition take place forward direction, but after a while, CO2 after combination will CO2 to form CaCO3 reverse direction. In the beginning, forward direction is fast and reverse direction is slow, but eventually the reverse direction speed up and both reactions go on at the same rate. At this stage, decomposition and combination take place at the same rate but at opposite direction. As a result, amount of CaCO3, CaO2 and CO2 do not change. It is written. When we think of the term equilibrium, the first word that usually come to mind is balance. However, the balance may be achieved in a variety of ways. Thus, when the rate of the forward reaction is the same as the rate of reverse reaction, the composition of the reaction mixture remain constant. It is called a chemical equilibrium state. At equilibrium state, there are two possibilities. When reaction ceases to proceed, it is called static equilibrium. This happens mostly in physics phenomena. For example, a building remains standing rather than falling down because all the forces acting on it are balanced. This is an example of static equilibrium. When reaction does not stop, only the rates of forward and reverse reaction become equal to each other but take place in opposite direction. This is called dynamic equilibrium state. Dynamic means reaction is still continuing at dynamic equilibrium state. Rate of forward reaction is equal to rate of reverse reaction. In a reverse reaction, dynamic equilibrium is established before the completion of a reverse reaction. It is represented graphically in figure 9.3. At initial stage, the rate of forward reaction is very fast and reverse reaction is taking place at a negligible rate, but gradually forward reactions slow down and reverse reactions speed up. Eventually, both reactions attain the same rate. It is called a dynamic equilibrium state. For example, in case of reaction between hydrogen and iodine vapor, some of the molecules react with each of other to give hydrogen iodide. At the same time, some of the hydrogen iodide molecules decompose back to hydrogen and iodine. In the beginning, as the concentration of the reactant is higher than that of the product, on the rate of the forward reaction is faster than the reverse reaction. As the reaction proceeds, the concentration of reactant will gradually decrease, while that of a product will increase. Constantly, the rate of forward reaction will go on decreasing and the reverse reaction will go on increasing, and ultimately the two rates will become equal to each other. Thus, the equilibrium will set up and concentration of various species become constant. It is represented as microscope characteristic of forward and reverse reactions. Forward reaction. It is reaction in which a reactant react to formed product. It takes place from left to right. At an initial state, the rate of forward reaction is very fast. It slows down gradually. Reverse reaction. It is reaction in which a product react to produce reactant. It takes place from right to left. In the beginning, the rate of reverse reaction is negligible. It speed up gradually. Microscope characteristic of dynamic equilibrium. A few important characteristics of feature of dynamic equilibrium are given below. An equilibrium is achievable only in a closed system in which substance can neither leave or enter. At equilibrium state, a reaction does not stop. Forward and a reverse reaction keep on taking place at the rate but in opposite direction. So guys, please सब्सक्राइब माई चैनल एंड प्रेस द बेल आइकन। अगली वीडियो में मुलाकात होगी, तब तक के लिए अपना ख्याल रखिएगा। अल्लाह हाफिज़।